Kritik, unmute yourself and tell me the screen is visible and audible.
Sir.
Okay. Now you write down first title, special welding processes. Special welding processes. Below that write down resistance welding. Resistance welding.
Exactly 7.
Hello? Shall I start?
Yes, sir.
Okay. Say the special welding process in that first one, resistance welding. The name itself indicates resistance. Resistance is created between the workpiece by the flow of electric current. Due to that, the heat is generated. The heat utilized for joining of two metal pieces or two sheets, and which works on the principle Joule's law. First, all of you write down resistance welding. Resistance welding. Below that, write down the resistance welding. Resistance welding works on the principle of Joule's law. Joule's law. That is Q equal to or proportional to Q proportional to I square or T. I square or T. Below that, write down Q equal to 0.24 into I square or T. I square or T. Where Q heat generated in calories. Heat generated in calories. Next line, write down 0.24. Constant of proportionality. Keep the equation in a block. Q equal to 0.24 into I square or T in a rectangular block. Below that, write down where Q heat generated in calories. Next line, write down 0.24. Constant proportionality constant. Next line, write down I square. The current flows in the circuit. In amperes. Current flows in the circuit in amperes, or below that, write down or hyphen resistance in the circuit in ohms. Say below that, write down in resistance welding. In resistance welding, the resistance created in between the workpiece. Due to the resistance comma, heat generated, which is utilized for different types of resistance welding, such as spot welding, comma, seam welding, etc. All of you observe here. Say the flow of electric current in the circuit, the thin sheets of thickness 1 millimeter or 2 millimeter. For this good example, all of you have almirah in your house. You just open and see the door of the almirah or backside of the almirah, which is joined by resistance welding process, that is spot welding process. At a distance of 10 centimeter or 20 centimeter, they join the sheets to the other sheet by using spot welding process, spot resistance welding. All of you observe here the diagram. This is the electrode of the spot welding. These two are sheets which are connected by electrical circuit through the transformer, and this is the timer unit, and this is the AC power source. So once if you switch on the electric current, the resistance is created, the electrode presses opposite direction of the sheet. A nugget, a balls type of joint is formed between the two sheets. The joint is created in the spot, that is called spot resistance welding. Spot resistance welding. All of you observe here the spot between the two sheets of mild steel or low carbon steel or mild steel are joined by a spot welding. The name itself indicates a spot, a particular spot. You can make the joint, that's called spot welding. And below that, write down the current of 105 to 300 amps is used. 105 to 300 amps of current and the voltage of 25 volts, which create the resistance. In turn, due to the resistance, the heat is generated. Full stop. The AC source is used for resistance welding. Next paragraph, write down in inverted commas. The sheets are to be joined, or the parts are to be joined. Are heated to a plastic state by creating resistance and high pressure is applied. Next, all of you write down types of resistance welding. Write down one by one. butt welding. Number 1, butt welding. Number 2, spot welding. Number 3, seam welding. Number 4, projection welding. First, spot welding. As already we discussed, the spot welding. This is used for joining of sheets. Good example for this is almirah, racks, and the furnitures. Next, butt welding. Joining of two sheets or rods by using electrical resistance. All of you observe here, this is the fixed clamp, this is the moving clamp, and you can introduce the workpiece along with the pressure and make the contact, create the electric current, pass the electric current. The resistance is created between the workpiece. Due to the resistance and heat of temperature up to 2000 degrees created, and the joint is formed between the two workpieces. This diagram indicates the principle of application of resistance butt welding. And you have advantages and disadvantages application of resistance welding. Say the advantages: no filler rod is required, the process is fast, anybody can control the welding process, both similar and dissimilar metals can be joined, and the process is very clean, does not produce any harmful gases. So like this, you have a lot of advantages. Disadvantages: the cost of the initial equipment is high and the maintenance of the equipments are high. Nowadays, electric current is cost of the electric current is also high. So these are the disadvantages. Applications: manufacturing of almirahs, joining of sheets, bars and rods, and used in body of the automobile, body of the aircraft, and general fabrication work. You can use resistance welding. So this is the explanation for spot welding, and this is the seam welding. Say in some applications, for example, the boat or ship, aircraft or automobile, you require the continuous joint like this. All of you observe here and write down. Number 3, seam welding. Seam, no gap. Seam means no gap. So it looks like a spot welding, but the thing is the sheet is passed between the roller electrode and the two sheets which are to be joined, which is passed below the circular electrode on front side and back side. They spray the cold water in order to cool the joint. Then the joint is made between the two sheets, which produces continuous welding. That is called seam welding process. Seam welding process. All of you observe here, these two sheets are connected by weld. This is the seam weld or continuous weld. That's called the seam resistance welding. Next, come to the point, projection welding. All of you write down. Number 4, projection welding. Join the sheets or workpiece by using the dimple or projection of the weld plates. You can join two sheets by using the spot weld by projecting the dimple of the electrode, which create the resistance between the two workpieces and can fix at some places at distance in the sheet. All of you observe here. The name itself indicates the pressure is applied, the dimple is formed. In the dimple, joints are created between the center. One is movable electrode, other one is fixed electrode, which makes the joint like this. This is the explanation for projection welding. Next, come to the point, in the special welding process, the friction welding. Friction welding. Write down the title, friction welding. say creating a friction in between the two workpiece. From that also you can join workpieces, which looks like a butt shape in the end of the workpiece. So this is the concept using the friction welding. So three types of steps or the methods used in friction welding. First, fix the workpiece in a chuck like this and rotate the component at a speed of 5000 rpm or even high. That makes the friction between the two workpieces like this. Due to that friction, the heat is generated from the pressure from the backside. The butt is created. The workpiece is joined to the rotating workpiece. This is the one method of joining of two workpieces due to friction between the workpieces. One is fixed one, other one is rotating one. See, rotating the workpiece, all of you observe here, rotating one. This is the fixed one, this is the rotating one. The butt is created due to the rotation of the workpiece. And also sometimes they use the vibrating mechanism or some type of special mechanism so that they can fix the workpiece into another by rotation of the workpiece or friction of the workpiece. The friction may be created by motion of the workpiece in clockwise or anti-clockwise direction with the RPM 5000 RPM, which is maximum enough. The friction creates the heat between the workpiece and joins the workpiece like this. All of you observe here. This is the special type of friction welding. This is a special welding process, friction welding. This is the explanation for friction welding. See the application of friction welding. What are the parts to be joined by friction welding? Pipes, stainless steel pipes, brass pipe, bronze pipes, ferrous and non-ferrous tubes, bars, carbon steel, stainless steel, aluminum, titanium alloy, and all the similar or dissimilar hard, soft metals can be easily welded by using friction welding process. Next, come to the point, explosive welding. Explosive welding. What is explosive welding? That is nothing but the explosive, usually gunmetal, RDX, ribonucleic nucleic acid, and other chemicals which have the properties of explosion that is used. The common explosive available is gelatin stick and the ammonium nitrate, and sometimes they use RDX also for joining of two metal pieces. All of you observe here. This is the base on which they place the base plate and the flare plate, and the explosive placed here. Due to the explanation of the chemical, the heat is generated and the workpiece is connected to the base metal due to the explosion of the chemical, usually aluminum nitrate, ammonium nitrate, RDX, gunpowder, sulfur and phosphorus and other chemicals are used in explosive welding. So all of you observe here, this is the jet and this plate is joined to the base metal due to the explanation of the explosive material, and you have a clad metal which supports the workpiece. Just go through the one by one. This is the anvil, base metal, jet, the flare plate, clad, and the workpiece to be joined, and this is the explanation. This is the direction of detonation. Once the explosion takes place, this metal is joined to the base plate due to the explosion of chemical. So this is the special type of explosive welding. This is one method, but the advantages, disadvantages, limitations, and are very high in explosive welding. In very few cases, they use explosive welding. Next, come to the point, all of you write down, thermit welding. Mark it very important. Mark it very important. Many question papers, you have this question in the examination, that is thermit welding. Thermit welding, chemical used for joining of railway tracks. All of you observe in this diagram, the person heating the chemical in the cruise crucible or ladle and make the chemical to fall in the joint between the two railway tracks. So the smoke is coming from the burning of the chemical. What are the chemicals used in thermite welding? Just all of you observe here. Aluminum oxide, iron, which produces 7193 kilocalories of heat. This is copper oxide, and aluminum, which produces aluminum oxide, which also produces the heat of 275.3 kilocalories of heat. This is maximum enough to melt the ends of the railway track. All of you observe here. This is the principle of operation of thermite welding. The chemical aluminum oxide or copper oxide placed in the thermite mixture, and this is the two railway tracks or I section. They have made the joint, and this is covered with the two box type of structure or box, mold box, and they make the flow of thermite mixture into the gap which has the temperature of more than 2000 degrees centigrade. This is the maximum enough to melt the two ends of the railway track. So all of you please write down the question. Explain briefly with neat sketch. Explain briefly with neat sketch thermite welding. Explain briefly with neat sketch thermite welding. Put a question mark. Put a question mark. List advantages and disadvantages. For this question, write this 2D diagram, explain the principle of operation with your own sentence, and write the chemical reaction. Al2O3 reaction takes place between the iron, produces enormous amount of heat, which is maximum enough to melt the ends of the railway track. And also one more reaction, copper oxide with aluminum produces aluminum oxide, that is metal, that's the which produces enormous amount of heat, that is maximum enough to melt the ends of the workpiece. This is the principle of operation of thermite welding. So this is the principle of operation of thermite welding. Next, come to the point. All of you write down laser welding. Laser welding. In bracket, write down laser beam welding. Laser beam welding. First, this is the ruby crystal. This is the ruby crystal, which is controlled by transformer with high voltage current. Due to supply of high current to the ruby crystal, which produces radiation, that you can call it as the laser light amplification stimulated emission radiation coming from the ruby crystal, which is placed in a box type of structure, and this radiation, that is laser, utilized for welding of two sheets. So you can join the two sheets at some spots are possible. So principle of operation of this is the gun. From this you have the laser which is impinge on the workpiece joint, or which hit the joint and fills the gap with the electrode material or filler metal, and the laser has the radiation which is maximum enough to melt the edges of the workpiece as well as the filler metal so that you can fill the gap by using laser. Remember, ruby crystal. Ruby crystal. If you provide the electric current, ruby crystal produces radiation. That radiation is utilized for welding of the two workpieces. The radiation is called as laser, light amplification, stimulated emission radiation, laser. See, this is also a spot welding process, but you are using laser and you have advantages, disadvantages, limitations, and applications. In some of the components which are used in operation theater, aircraft, spacecraft, automobile, and some of the components are joined by laser welding, and also aesthetic look of jewelry making, and also silver utensils used in temples and puja. So those things are welded by laser welding. So laser welding produces clean, simple, and strong joint, but the initial cost of the equipment is very high, and the experienced worker is required, and the other some advantages, disadvantages always present in any type of welding process. This is the special type of welding process used in joining of components used in automobile, aircraft, spacecraft. So this is the principle of operation of laser welding. See, all of you observe here, ruby is aluminum oxide, Al2O3. So you have advantages, disadvantages, and applications of laser welding. Next, come to the point, all of you please write down electron beam welding. Electron beam welding, EBM. In bracket, write down EBM. And all of you observe here, this is the filament, tungsten filament, and if you provide the voltage to this tungsten filament, which produces electrons, these electrons is made to fall on the workpiece surface where you require the joint. All of you observe here, this is anode, this is cathode, this is the tungsten filament which is receives the electric current, starts to produce the electron, and these electrons are made to fall on the workpiece joint, and the joint are heated to maximum temperature and maximum heat. That heat is enough to join the workpiece. The electron is produced from tungsten filament. All of you observe here, once you supply the electric current and voltage to the filament, tungsten filament start to produce the electrons due to placing of cathode and anode, and the grids which makes the electron to fall on the workpiece. Say this is the electric supply to the filament, and this is the control of horizontal grid and vertical grid, so that the electrons are made to fall on the workpiece joint. That electron has the frequency or intensity of heat, producing heat that is maximum enough to melt the surface of the workpiece to be joined, and the workpiece is placed inside the vacuum chamber. Remember, the inside the vacuum chamber, so that you can join the workpiece by using electron beam. So this is the principle of operation of electron beam welding. So which produces clean joint. The process is simple, and the sheets, very thin sheets, very thick sheets can be easily welded. The application of electron beam welding is the components or sheets are joined using in automobiles, aircraft, spacecraft, chemical industries. So the workpiece are joined by electron beam. So this is the principle of operation of electron beam. and advantages, disadvantages, and applications. Now I stop at this stage. This completes the fourth module. Before that, write down a question. Explain briefly with neat sketch electron beam welding. Electron beam welding. Put a question mark. List the applications and limitations. Next question, write down. Explain briefly with neat sketch laser welding. Laser welding. Laser welding. Next line, write down. One more question. What is thermite welding? What is thermite welding? Put a question mark. Explain briefly with neat sketch thermite welding. Thermite welding. Next line, write down. One more question. Explain briefly principle of explosive welding. Explosive welding. Next question, write down. With suitable figure, explain briefly friction welding. Friction welding. Put a question mark. Least advantages and disadvantages. Advantages and disadvantages. Next line, write down. What is resistance welding? What is resistance welding? Put a question mark. With neat sketches, explain briefly the types of resistance welding. Types of resistance welding. This completes the fourth module. I will start the fifth module Monday. Now all of you unmute yourself and write your name and USN in the chat box. Answer roll call. Hemant. Shashank. Okay, Hemant. Shashank.
Yes, sir.
Aditya,
Yes, sir.
Harshavardhan,
Yes, sir.
Prathamesh,
Yes, sir.
Mohammed, Hemant KS,
Present, sir.
okay, Anush, Pratik S, Dhanush, Abhiram, Prema H, Pawan HR,
Present, sir.
Sharath Madik, Kumaraswamy, Nazma Khan,
Yes, sir.
Mohammad Raza,
Yes, sir.
Chetan,
Yes, sir.
Nutan,
Present, sir.
Kumaraswamy, Harsha Ahmad,
Present, sir.
Danish Bhatt,
Present, sir.
Nayaj,
Yes, sir.
Lohit,
Yes, sir.
Nishchit,
Present, sir.
Jishan,
Present, sir.
Mohammad Raza,
Yes, sir.
Krutik.
Yes, sir.
Anybody else? Please tell me your name.
Sir, Aditya.
Anush. Okay. Next.
Aditya.
Aditya. Okay. Next. Okay. Now I stop at this stage. I will continue in the next class.